Greetings everyone, and welcome to the next video in my lecture series on differential equations. We're still working on Laplace transforms, and in this video we are doing examples of initial value problems, or IVPs, involving translations on the s-axis. So for this example, we're solving 2y double prime plus 20y prime plus 51y where our is equal to 0, where our initial conditions are y of 0 is equal to 2 and y prime of 0 is equal to 0. So we're first going to take the Laplace transform of both sides. So we're going to be taking the Laplace transform of y double prime, Laplace transform of y prime, and the Laplace transform of y. And so we're going to get 2 onto square bracket s squared capital Y sub s, y of s, minus s y of 0, lowercase y of 0, minus lowercase y prime of 0, where everything inside the square brackets here is equal to y double prime, or the Laplace transform of y double prime, sorry, plus 20. Now we're taking the Laplace transform of y prime to get s capital Y sub y of s minus lowercase y of 0 plus 51. Oh, let me go back and highlight that everything inside the square brackets here is y prime. And then plus 51, we want the Laplace transform of just lowercase y, which is uppercase y of s. And then that's equal to 0. Please, once again, be careful and make sure that you can tell the difference between your uppercase y's, which is the Laplace transform of our function, and the lowercase y of 0 and y prime of 0, which are our initial conditions. Now, applying our initial conditions, we can see that y prime of 0 is 0, so any y prime term goes to 0, and y of 0 here is equal to 2. So these two terms here are equal to 2. This gives us 2, and multiplying through here, s squared y of s minus, so it's 2 times negative s times 2, so negative 4s, plus the 0 is going to go away, and then we're going to get plus 20 sy of s minus 2, and the 20 times 2 gives us negative 40, and then plus 51 y of s is equal to 0. Pulling out our y sub s terms, we get that y sub s onto 2s squared plus 20s plus 51 minus 4s minus 40 is equal to 0. And so we're going to solve for y sub s here. We're going to move the 4s plus 40 to the other side, and then divide by the 2s squared plus 20s plus 51. Now, the denominator here looks a little unlovely, so what we're going to do is just over on the side, we're going to complete the square. We get that 2s squared plus 20s plus 51 is equal to 2. We're going to pull up 2 to get s squared plus 10s plus blank plus 51 minus blank. What we want is the term in the round brackets makes the thing inside the round brackets a perfect square. So that take the 10 divided by 2 to get 5 and square it to get 25. But what we've actually added is 2 times 25 because of the 2 outside the round brackets. So we're going to subtract 2 times 25. And that gives us 2 onto s plus 5. Make sure that your 5s are nice and exaggerated so you can tell the difference between them and your s's. And then plus 51 minus 50 gives you a 1. So going back over here, I'm just going to complete my box. So going back to our expression for capital Y of s, we get 4s plus 40 over 2 onto s plus 5 all squared plus 1. Now this is starting to look like something we can take the inverse Laplace transform of, it sort of looks like a sine or cosine term, but what we actually want on the bottom is s minus a squared plus omega squared without the coefficient of 2 on the front. So the easiest way to deal with this is divide the top and bottom by 2. You're going to get 2s plus 20 divided by s plus 5 all squared plus 1/2. Now, this kind of is starting to look like what we'd like, except what we really want is something that looks like 2 onto s plus 5 plus some other constant term over here, which we'll figure out in a second, over s plus 5 all squared plus 1/2, because we want our s plus 5 squared in the bottom to be matched with an s plus 5 on the top, so that it looks like a cosine that's just been shifted. And so we have to figure out how to make this work. So we're taking a 20 that we had previously, but notice that with our writing the 2s plus 5, we essentially added a 10, and so we're going to subtract that 10 to balance it. And so we get that this is 2 onto s plus 5 over s plus 5 squared plus 1/2 plus 10 onto s plus 5 squared plus 1/2. And of course you could leave it as a single fraction if you wanted to. Just want to emphasize the fact that these two expressions will give us two different terms when we take the inverse Laplace transform. So now we're going to go ahead and take the inverse Laplace transform of both sides. And so then the inverse Laplace transform of capital Y of s becomes lowercase y of t. For our first term, that looks like a cosine with a shift of 5, positive 5. So we're going to get 2, and then the shift of 5 gives us e to the 5t, and then we're going to have a cosine, and then we're going to look at the omega squared. Omega squared here is equal to 1/2, and that means that omega is 1 over root 2, and so taking the cosine of t, omega t, which will be t over the square root of 2, and then similarly the second term. What we actually want to have in the second term is we want to have omega over s squared plus omega squared. And so the easiest way to do that is to say, okay, I'm going to multiply the second term by 1 over the square root of 2, and then I'm going to put square root of 2 in the top. And we're essentially multiplying by 1 here, but that then gives us, wait a minute, that is not what I want. I wanted a 1 over square root of 2 here, which is omega in the top, and that means that we're going to multiply by square root of 2 on the outside. And so we're going to get 10 times the square root of 2 times sine of t over the square root of 2. And we're done.